So that's what node is. And a transaction is nothing but like a distribution taking place between two nodes within the blockchain network. As simple as that. So moving forward, what is a block? A simple, like a blockchain is comprised of two words, block and chain. I mean, in simple terms, in layman's term, blockchain can be referred in block as well as a chain. A block is nothing but a data structure used for keeping a set of transactions which is distributed over all the nodes in a network, right? And a chain refers to a sequence of blocks in a specific order, right? So like when two how are two blocks connected to, like through a chain. So a chain simply refers to that. And moving forward, there are two other important terms which we will be using in our workshop, which are miners and consensus. So what is a miner? A miner is a specified or a node given some extra special access, which performs the process of block verification and block production. Like a mine and or like a miner is a node which is capable of producing a new block on its own, right? Right, right. So moving forward, what's a consensus? A consensus is a set of rules and arrangements to carry out blockchain operations, right? So like I mean, in any administrative system, like any network, we need to have a set of rules and regulations like to administer the network, right? So similarly, in a blockchain network, we are using something called as a consensus protocol, which consists of many subtopics like proof of work, proof of stake, like which we'll be discussing further. And so basically, consensus is a set of rules and arrangements to carry out blockchain operations, right? So this is what blockchain. So moving forward, these are the key elements involved in blockchain technology. So when you're talking about the key elements involved in blockchain technology, the first thing which comes to our mind is distributed ledger technology, right? So one second. Right. So it is distributed ledger technology. So distributed ledger technology is basically comprising of a few topics like cryptography, decentralization, transparency, anonymity. All these topics come under distributed ledger technology. Okay, let me explain them one by one. And so what is a digital under digital ledger technology, we have decentralization. Decentralization means, in simple terms, no central authority, like meaning a DLT or a digital ledger technology operates on decentralized network of computers or nodes rather than a single central authority. So and each node has its own copy of a ledger. You may ask me what a ledger is. A ledger is nothing but a record keeping system where all the transactions are stored, in simple terms. So next, what we have is a consensus mechanism. So in a DLT network, a consensus or consensus, the validity of transactions without the need for central authority is given. And this is given so as we know that all blockchain in all the blockchain is basically decentralized. So in this case, we don't need a central authority giving us permissions. Instead, we use something called as a consensus mechanism, through which we ensure that all the nodes agree on the state of the ledger. So moving forward, what is immutability? As I've mentioned, immutable records. What is immutability? Immutability means once a ledger is created or once a block is created, it becomes extremely difficult to alter the block. I mean, it becomes practically impossible to alter the block. So this immutability is achieved through cryptographic techniques and consensus mechanism in fact, right? So and this, what does this do? This ensures the integrity of data. Once the data is created or once the data is added to a block, once a block is created in a blockchain network, it is extremely difficult to alter it. It stays there permanently. And moving forward, I'll be talking about what is transparency. All participants in a network have access to the same ledger. So, meaning that the level of visibility of the blockchain is same across all the nodes of the network, right? So this makes it transparent. And however, there is some level of visibility specific for specific transactions, which may be varied depending upon the distributed ledger technology (DLT). And moving, yes. So now the last important key element involved in blockchain technology is cryptography. And cryptography ensures security in simple terms. And how does it do it? DLT relies on cryptographic techniques to secure transactions and control access. This is done by giving each node a private key for signing transactions and a cryptographic hashing which ensures data integrity. Right. So cryptographic hashing is used, and the hashing technology which we'll be using in blockchain net, is basically SHA-256 algorithm, which generates a 16-bit value. Right. So moving forward, as I mentioned, cryptographic keys, a peer-to-peer network containing a shared ledger. I mean, there is no one central authority maintaining the entire flow. I mean, all the peers or nodes, have the same level of visibility of the blockchain in network, right? So as we read, a means of computing to store transactions and records of the network. So this is what these are the technologies used in blockchain. So now going to the main important part, which is the working of the blockchain technology. So the working of the blockchain technology, as we see, um, an authorized participant inputs a transaction which must be authenticated by the technology. Okay, let me explain these 5 points statement by statement, so that you understand it better. So when we mean an authorized participant, we mean an authorized node, but which initiates a transaction by entering some relevant information, right? And and having the necessity permissions to initiate such a transaction. Now the authentication of the transaction is must go through a process of other transactions to form a block, right? A block is nothing but a group of so basically let me explain it again. The entire transaction must go through a process of authentication. That's clear. This often involves cryptographic methods to ensure that the transaction is legitimate and authorized, right? So speaking of which now, as we see here, uh, we see one of the important points. That action creates a block that represents a specific transaction or data. So what we mean by this is, once the authentication is done, the transactions are bundled together with some other transactions to form a block. A block is nothing but a group of transactions or data that is ready to be added to a blockchain, right? A blockchain is nothing but a chain. A blockchain is nothing but, as we mentioned, it's a network of blocks. I mean, where each block is connected to another block with in simple terms, with chains, right? Right. As simple as that. Yes. So moving forward, as we can see, the block is sent to every computer node in the network. So, the one of the main important key features of blockchain, as we already mentioned, is decentralization, and this is done. So that this is done like how is this done? Is basically the newly created block is broadcasted or sent to every computer node in the blockchain network. So once so in such a way, each node holds a copy of the entire blockchain, making the network decentralized. Decentralized having meaning there's no one central authority, right? So then moving forward, we have the authorized nodes validate transactions and add the block to the existing blockchain. So this means that, whenever a new node, every node in the network, like especially the ones which are authorized to make a transaction, and when they create a new block by making some transactions, this block is added to the blockchain network by passing through an authentication process. So this process is pretty complex, as it involves it has to pass through all the consensus mechanisms, like the proof of work, the proof of stake, POS and POW. And once this is done, the block is added to the blockchain, and this blockchain is again distributed to all the nodes in the network. So that is this updated blockchain is now distributed to all the nodes in the network. This ensures that every participant has the latest version of the blockchain. Right. So and finally we have the finalization that the update is distributed across the network, which finalizes the transaction. Right. So that's how it is. So now all the nodes in the network are aware of the new transaction which has been made by some other block in the network, and when a block is created, it is immutable and it is transparent, as all the nodes are able to view what block is being added. Right. So this is what the working of blockchain is. So moving forward, we'll be talking about the components of blockchain. That is a node, a ledger, a wallet, a nonce, and a hash. So going in depth, so we'll start with what a node is. Um, so as I mentioned already, a node is nothing but a computer or a device that is a part of the blockchain network, as we've already mentioned before. But we are basically any end user or a computer being a part of the blockchain network can be referred to as a node or a peer, right? Um, and each node stores a copy of the entire blockchain and participate in validation and verification of transactions. Right. So now speaking under node, we have you have two different types of nodes. It's called as a full node and a partial node. But yes, a full node is basically uh, a node which is a node which has all the properties that of a standard blockchain. That is, it has to be decentralized, it has to pass through the consensus mechanism, it has to, and that node has to have all the updated blockchain. That is, it has to have the updated blockchain. So a full node is basically a blockchain that maintains a complete copy of the entire blockchain. Right. And what's a partial node? A partial node, this may not standardize with the blockchain technology. However, such a node does exist, and it refers to a node that doesn't store blockchain locally or doesn't actively participate in all aspects of the network's operation. Right. So what do we mean by this? We mean that this such a node does not contain the all the transaction history present. That is, if a new block is created, it won't be reflected in a partial node's shared ledger. If you understand what I'm saying, right? So that's what it is. The entire blockchain is locally not present on the partial node, which does not standardize to blockchain technology. However, these nodes do exist because of few topics which we'll not be discussing right now. So moving forward, I'll be talking what a ledger is. So what now? Speaking of a ledger, as I already mentioned, it's an online notebook. So basically, it's a record keeping component of blockchain, and it's a distributed database that contains chronological and secure record of all transactions made on the network. Right. Each node in the blockchain network has its own copy of a ledger, as I mentioned, a full node, and ensuring transparency and redundancy. As I mentioned, what transparency has every node in the blockchain network will have a copy of the entire blockchain. So now, as I've showed you the image here, node A, node B, node C, node D, all of them share the same ledger, as you can see, right? And all these nodes are interconnected to each other. There's no one central authority, as you can see from this picture. There's only a node to node or a peer to peer connection, right? So now, what is a public ledger, a distributed ledger, and a decentralized ledger? Um, yeah, 1 second. Yes. So speaking of a public ledger focuses on accessibility, allowing anyone to view transaction details. As simple as that. This is a standard blockchain network, in a standard blockchain network. And moving forward, what is a distributed ledger? Distributed ledger involves spreading the ledger across multiple nodes to enhance security and reliability. As simple as that. Yes. So moving forward, we'll be talking about what a decentralized ledger is. A decentralized ledger refers to a ledger where control and decision making are distributed across a network, with no single entity or central authority having the complete control. Right. So, as you can see from this image, there is no one central authority present in controlling these nodes. Right. So, this is the advantage, one of the advantages using a blockchain network. Moving forward, what is a wallet? So, it's a digital wallet. It's a digital wallet that allows users to store their cryptocurrency. So, let me explain this in a little more depth. So a wallet is nothing but it's a digital tool, as you mentioned. It's a digital tool that allows users to store, manage, and interact with their cryptocurrencies. As we all know, we all have a cryptocurrency wallet, like a Bitcoin wallet or an Ethereum wallet. So what we do, the users store, manage, and interact with with their cryptocurrencies, and it consists of a pair of cryptographic keys. So how does it work? And every wallet consists two keys, and these two cryptographic keys. One a public key, it's also known as a wallet address, which can be accessed by anyone. And second one is a private key, which is only known to the owner. And what are these wallets used for? These wallets are used to send and receive cryptocurrencies and monitor the balance of the associated addresses. As simple as that. Now, as we can see, the photo here, this stands for Bitcoin, this stands for Ethereum, and so on. So there are two types of wallets. One is a hot wallet and a cold wallet. So, so explaining what a hot wallet is, it's a cryptocurrency wallet that is connected to the internet, either directly or indirectly. I mean, it has to be connected to the internet. Hot wallets are convenient for frequent transactions and for day-to-day spending or trading. If you see an example of a hot wallet, example online wallets, as we can see, I mean, any online wallet where you can store, like suppose we take an example of Amazon. It stores. You have an Amazon Pay, right? So Amazon wallet is there, on even similarly, and on a Uber wallet is there. So in such examples, we're using an online wallet so that it's a convenient, and it's easy to use day to day. And then moving forward, what are the characteristics of hot wallet? It's connected to the internet and is convenient for trading and transactions. However, there's one disadvantage related to hot wallet, which is higher risk of hacking. I mean, it's not wise to save your data, your card details or your bank details on such wallets, because there's a high probability of it getting hacked, or an unauthorized access to your wallet. So now, moving forward, we have something called as a cold wallet. And a cold wallet is nothing but it's another type of cryptocurrency wallet that operates offline, and it's not directly connected to the internet. So, and we consider cold wallets to be more secure and less vulnerable to hacking attempts, or online security breaches. They are suitable for long-term storage of cryptocurrencies. I mean, if you want decades of storage, right, we go for cold wallets. It is not. It's a completely offline cryptocurrency wallet. And so, what are a few examples of cold wallets? If you see, we have hardware wallets, physical devices. We have paper wallets, like printed or written record of wallet information, etc. And what are the key characteristics of cold wallet? It operates offline, and it is less convenient for frequent transactions, because we need to connect to the internet while accessing the funds, right? But however, there's a very good advantage is that it is ideal for storing larger amounts of cryptocurrencies very securely. So there won't be any problem of there won't be any known potential problems involved through hacking, or through any malware or viruses, right? So this is what a digital wallet is, and then going into what a nonce is. So a nonce is basically it's a 32-bit number generated randomly only one time, that assists to create a new block or validate a transaction. As I already mentioned, the creation of a block. So how is it done? So a nonce stands for number only used once, as simple as that. And in context of blockchain, It is a 32-bit arbitrary number. Let me explain that to you. That is included in the block header, right? So a block usually consists of the block's hash, the previous block's hash, like, so that it remains interconnected, so that every block is connected to and every block is connected to every other block, right? And yeah, so the nouns ensures that each block is unique, and finding the right nouns is a part of the proof of work consensus mechanism, which we'll be discussing further in this workshop itself. So miners have changed the nouns value in process called mining to find a valid hash that meets a certain criteria. As simple as that. And as you can see, this SHE-256 algorithm is used to create a new block. SHE-256 algorithm it provides a 16-bit value, which ensures data integrity and security. All right. So next, we're going to talk about hash. So hash is another key component of blockchain technology. So, what is a hash? A hash is a cryptographic function that converts input data into a fixed size string of characters. As I mentioned, 16-bit. In case of, yeah, right. So, transactions are and blocks are hashed to create a unique identifier. In meaning, hashes are used for security and efficiency. As we mentioned before, it maintains block security. So no one with any unauthorized access can remove the block or modify or alter the block, right? Even however, this is very important to note that even a small or the slightest change in the data or the information provided within stored in the block can result in completely different hash, right? Right. Which is making it easy to detect alterations. As simple as that. So we can see here, there's an input hashing algorithm, and this is the hash output. This hash output is stored in the block. This in a block, along with this, we also store the previous hash block. As simple as that, along with the input what we have given here. Right. So we've already done with the applications right now, and we'll be yes, as you can see, these are the applications, and we'll be moving forward to a very important topic within the blockchain network, which is referred to as the P2P network. And I'll hand over this to Ritvik. Ritvik, please take the floor.
Hello everyone. Up to this part, if you have any doubts, you can comment down. As Harsha explained all the terminologies related to blockchain. No, that's okay. Okay. Any doubts? Any?
Yeah, there are no doubts. Ritvik, please continue.
So okay. Yeah. Coming to P2P network. P2P network is a decentralized network structure with each node acting as a both client and server side. So in P2P network, there is no central authority responsible for managing the data, and so by this we can achieve scalability and less dependencies. So let's say if there are dependencies on server side, and so if the server fails, so the client's architecture might be failure. So in P2P network, there is no such thing as central authority, so it might be advantageous in this P2P network. So in this next slide. Okay, what's consensus mechanism? So consensus mechanism is so if you, so let's say if you have five blocks, right? So as 5 different nodes, right? So if you have the copy of same blockchain, so let's say we have done a transaction, and and there will be addition of one block to a to the entire blockchain. So but then which node will add the so but then which node will add the this thing. So so to solve this problem, we use consensus algorithms. So there are many consensus algorithms like proof of work, proof of stake, proof of delegated proof of stake, delegated proof of authority. So there are many. So in this workshop, we'll be discussing mainly about proof of work and proof of stake. So what's proof of work? So so before dwelling into proof of work, we have to understand what's a consensus, how the consensus mechanism actually works. So if you want to add a block, so if you want to add a block to the blockchain, so if you want to add a block to the blockchain, uh, there should not be a you know malicious malicious things. So if in proof of work, what happens is the node will solve a computational puzzle or a problem. So why why the proof of work will be used, like, so if we use proof of work, in proof of work, what happens is the node will solve a computational problem or a puzzle. So so the if if you are malicious, so there is no possibility of doing do, doing wasting so much of computational energy. So there is no possibility of malicious thing. So uh, proof of work was firstly introduced by Bitcoin. So coming to proof of stake, in this proof of stake was introduced by Ethereum blockchain. So right, Ethereum founder Vitalik Buterin. So in proof of stake, what happens is the nodes will invest some stake. If you want to say tokens, if you say nodes will invest some tokens. So if you have tokens, so if any malicious things happen, if there is any possibility of malicious things, so there will be so there will not invest, right? So that's why proof of stake is much better than proof of work. In proof of work, there is a waste of so much computational energy. And so there are articles like proof of work versus proof of stake, and you can read on blogs like. So and again, so coming to main component of blockchain, there are components like network participants and network topology. So network participants, as Harsha said, uh, nodes are the network participants in which a computer or a miner will act as a node. So in P2P networks, so there is an another term called network topology. In network topology, what happens is uh, in network topology we have centralized system, decentralized system, and distributed system. Our blockchain so let me ask a question. So how many of you think okay so how many of you think blockchain is distributed or decentralized? Let me get the comments in comment section.
Ritvik, I think you can proceed.
Okay, okay. So most of you think blockchain is decentralized, but actually, even in its name, most of them think it's decentralized. It's actually decentralized, but technically it's distributed network system. So if you search on Chrome, you'll get the centralized system, decentralized system, and distributed system. So it belongs to it actually is decentralized, but technically the network topology is distributed. And coming to advantages of blockchain, advantages of blockchain include immutability and transparency. So have you watched Kosla Ka Gosla movie? No, no. So in that, so let's say, if you buy a land from a person A, and after some days, and he'll be handing over the records and land papers, and after that, after some days, a person B will come, and he says that the land belongs to me, and he shows all the records and land papers, and it actually belongs to person B. but but after some days, the person A will run, uh, like he'll escape. So what, the person A will escape. So in you are being fooled. And so in blockchain, if you have if you s- so sorry so in blockchain, if you have there is a transparency, so there is a record of things happening, right? So so if the transactions happens, there is a record of every transaction, which uh, uh, which is connected in chronological order. So there is a record of all the transactions. So, so that's it, I think. Proof of remaining tomorrow, we'll be discussing about the cryptocurrencies and many other things.
Hmm. Yeah, Ritvik, did you explain proof of stake again?
Yeah, proof of stake. Okay. Yeah,
Yeah.
explain.
Yeah. Okay. Okay. Fine. 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 Like, can you mention
Yeah,
it like again? Yes.
yeah. Okay. Proof of stake is a type of algorithm. Uh, in There are many consistent algorithms like proof
Yeah.
of work, proof of stake, delegated proof of stake, delegated. I mean, proof of authority, and many. I think six. So many algorithms are there. So the main algorithms which we mainly see are proof of work and proof of stake. Proof of work is actually invented by Bitcoin. Uh, in proof of work, we the nodes should be able to solve a problem, and which node will solve the problem first, that node will be getting the Bitcoin, in case of Bitcoin. So in proof of stake, you actually invest some crypto tokens. So if there is any possibility of malicious thing, so nobody will invest the crypto tokens, right? So in proof of stake, you have to actually invest some crypto tokens, some amount of crypto tokens, to prove that actually uh, you are not malicious. The transaction is not malicious.
Yes. Yes. Thank you, Ritvik. And
Any other?
yeah, so if you have any questions, please do ask. And then this session will be uploaded on YouTube, so you can have a look on the basics of blockchain if you want to revise the concepts again. Tomorrow, we'll be conducting the workshop at the same time from 5 o'clock, beginning at 5 o'clock. And then this will be a little more complex as it involves cryptocurrencies and smart contracts and the working of smart contracts. Right. So please do join. It'll be a great and a fun session. And tomorrow at the same time, 5 p.m. And that's all for today. Thanks. Thank you for everyone joining. Sure.
Thank you, everyone.
I'll send the PPT in the main Jarvis Club group. You can refer to it. Thank you,
Yeah.
everyone.
Thank you, everyone.